But you need, that wasn't a one, that was a lumen.
Oh, thank you. The trouble with unserifed fonts.
Should be 8183.38
And units.
lumen.
No.
I think mathematically you might be able to get away with that because it's lumens divided by a steradian.
Yeah.
And steradians don't really exist, but you'd be really confusing the reader if you put down lumens here for intensity. The more
Be
standard
watts,
unit.
wouldn't it?
Pardon?
Watts? No, that's
Not
watts.
watts.
No.
Yeah, Candela is. And so this gives you a measure of basically anywhere within that cone there, so from the source to there. If I moved closer and changed the size of this accordingly, so looking at now a much smaller area, I'd have this exact same luminous intensity, because the luminous intensity is dependent on the angle. The similar to the two-dimensional is if I have a certain amount of energy hitting that band right there, if I moved in and looked at the smaller band, it had the same amount of energy, it's just not spread out as much. Which brings us to the next vocab word in dealing with sort of effectiveness of light. How much of that energy that you've now produced, or how much of that brightness is actually hitting the surface? Now we can do it simple enough over here, because I told you what the area of the surface was, so we don't even care about the angle anymore. But if I looked at the illumination, or illuminance, in the lab that you're going to do tomorrow, I call it illuminance. The book calls it illumination. And the symbol, of course, is the letter E, because we don't use that enough. And this is the luminous flux divided by area. This is not force over area. We're not talking about stress here.
Couldn't they make it like an LF or something?
There are so many times I think they should have done something different, but. And so we end up with, what was our flux was 181, assuming the same light, 181.678 lumens divided by 0.2 square meters. And what do we end up with for the illuminance?
908.39.
And lumens per square meter was too much for them to write. So it's 908.39 lux. Quick check to make sure I didn't get my units backwards somewhere. Yep, good. All right, questions to hear? All right, so if I have a light bulb here, and I have a sensor, I have an area to the sensor, I can calculate, I can do the measurements, do the calculation, I can figure out what the area of that sensor is. As I move that sensor back, that area is still the same. The luminous intensity, make sure I'm doing it in the right place here. It is F over A, okay. My area stays the same, and so the amount of light that hits it is gonna drop off as I'm moving back. But also the angle, the solid angle is also getting smaller as I move my sensor back. So you need to be careful when you're reading a problem of if a light is being produced, if something is shifting, am I keeping the same angle or am I keeping the same sensor size? Now in the lab tomorrow, it's the same sensor size as you start moving back. And so we can actually do a couple of estimations here, or not estimations, shortcuts. Let's plunge into it. My words are escaping me today. So we started out with the flux over unit area. I know that my solid angle, right, let's see which I want to go on this one. Take a moment. Suddenly thinking two different things at the same time, which doesn't work well. It's 3 o'clock, why don't we take 5? Let me get my head back in it.